Hi there. Welcome to Architecting Resiliency, Recovery, and Reliability with Capital One. My name is Don Barber. I am a Principal Solutions Architect at AWS, and here with me today is Tanushree McCabe, a Senior Distinguished Engineer and Architect at Capital One. Really looking forward today. We're going to go into a lot on this area. But first, what we'll do is go over what we're talking about today. So first off is, why is this important? Why is this such an important topic area that everyone's talking about? Where Capital One was before they started thinking in this type of methodology. Then we're going to go into what those different pillars for site reliability engineering are, and how to use those pillars to actually design reliable systems. And finally, what Capital One was able to get to using all that information. So, why is this important? Well, technology is being used for more and more in our lives. It's become more critical as time goes on, and we could, basically not do without it anymore. And according to Gartner, the average cost of IT downtime is $5,600 per minute, or about $300,000 per hour. I mean, that's a big chunk of change. And AWS gives a variety of services in order to meet those requirements for resiliency, recovery, and reliability goals. A huge number available. And what happens is customers come asking for best practices and advice on how to take advantage of those services to meet those goals. We do have a lot of written material available in our well-architected framework. I mean, it actually makes up two of those pillars, the operational excellence and the reliability pillar. But what's happened is Capital One has actually led the way and actually deriving a lot of those best practices and whatnot. So we thought, what's better than actually asking Capital One to come and share some of their experience with us? And so Tanu's here today to do that for us. So Tanu, handing it over to you.
Thank you so much, Don. I'm so pleased to be here today. Let me take you back a couple of years and talk a little bit about where Capital One was and where our journey started. We've always been focused on providing a great customer experience. To that intent, a few years ago, we defined what we call resiliency tiers, which were our requirements to help our application teams understand what was needed to achieve high resiliency. In 2018, we then updated those requirements to take advantage of cloud-native capabilities such as scaling and multi-region. That way, our cloud-based applications, at that point we were now all in on the cloud, could really take advantage of the cloud-native capabilities to increase and improve our resiliency and our customer experiences. As a result, we also found ourselves now, in 2020, looking at incorporating principles of SRE, or Site Reliability Engineering. That led us to create a framework which has three pillars: building on resiliency, which is still defined as the ability to avoid or mitigating impact from an adverse event. We've also added recovery and reliability. Each pillar is quite important, and we'll spend the bulk of our time today going through each one of these. Ultimately, the three work together to output what we call stability. Stability is really important for our customer experience. We want our customers to be able to rely on our applications and have a stable experience using them. Our business requirements define the goals for our stability. For example, recovery time objective, or RTO, recovery point objective, or RPO, and service level objectives, or SLO. RTO means that this is the time that we can let elapse when a failure happens for returning to operations. RPO is basically a threshold around what is our tolerance for data loss if a failure does happen. And SLO ultimately guides our reliability goals for providing our customers with high availability experiences, low latency experiences, data freshness experiences, and things of that nature. So let's take a look about how we use these three R's to actually help architect and define a system. Starting with a very simple example, here we have a simple EC2 instance and it has a database. So perhaps this is equivalent to a Hello World application. Now let's go ahead and apply the three lenses. The first lens is resiliency. When we look at our simple application and we start to think about resiliency, we need to consider things like scaling. For example, is the application able to scale horizontally up or down? Up or down, both are important For example, if a demand it greatly increases and our application is able to scale up to handle that increase, that's a wonderful experience. However, if our application stays at that level and our demand decreases and our application doesn't scale down to adjust to that change, we may be incurring extraneous costs when we don't need to. Redundancy is another important consideration for resiliency. It's quite common to use redundancy to help increase our availability. So for example, when we use redundancy, we have multiple copies of a particular layer of our application. What that means is if there's a failure for a particular layer, then the redundancy helps us to continue operations or continue our application to be available. Capacity is another important consideration. In order for our application to actually scale, we need to make sure that the subnets that are available for that application have enough free IP space. Similarly, if our application is using other AWS services, we need to make sure that the AWS API rate limits are not going to be hit and the capacity is available in those services for our application to use them. And of course, there's capacity of the servers themselves to support the application. Given these three particular considerations, we may find that our simple system has been enhanced to look like the following. If you look at point 1, we've now included an auto-scaling group to allow our EC2 instances to horizontally scale up or down in conjunction with an application load balancer to spread the load. We've also now enhanced our data layer, so our RDS instance has gone from a single AZ to be a multiple AZ instance. It also includes built-in data replication. This does assume that the application itself is designed to be able to handle horizontal scale. The redundancy here allows this application to continue to be available in the case, for example, that one availability zone is no longer available. Another important aspect of this with the RDS layer is if, for example, the primary RDS instance fails, because we use redundancy and built-in data replication, we can easily promote an alternate RDS instance to take the place of the primary instance and continue operations. Next up, we have the recovery lens. Just as important as resiliency, recovery lens allows us to consider how exactly is the application going to recover and restore from a failure. So the first particular point is to understand what are the possible failure points. In order to understand the possible failure points, it's important to conduct a failure mode analysis. In a failure mode analysis, what you're basically doing is thinking through all the scenarios that your application supports, and you're thinking through both the happy path and the unhappy path to be able to identify all your points of failure. As you do this, you're also able to assess which of those failure points are actually critical and which are not. By that I mean you need to also understand what's the probability and impact of that failure. A critical failure may very well result in an outage. A non-critical failure may result in something undesirable, such as a performance degradation, but it's not as critical as an actual outage. Once we have a good understanding of our failure modes, that allows us to also understand our recovery stages and be able to define them. What I mean by that is, in an ideal world, we would handle one failure at a time. But sometimes there are compound failures or multiple failures, and we need to be able to understand our stages of recovery so that we can restore in a particular sequence that makes sense. This also allows us to understand from our failure scenario analysis which failure scenarios can we recover from automatically versus which ones may still perhaps require human intervention. This ultimately lets us produce our strategy and procedures for this particular application. For example, what is the failover strategy? What are the procedures and have they all been tested? It's very important that this goes beyond a tabletop exercise because it is in testing that we learn whether or not the expected behavior of the system in the stages of recovery actually matches what the system does when you run a failure test. Given that particular lens, this may be a likely result. So our previously resilient and highly available application is now augmented to support recovery. On the left-hand side, we have design time automation. This is super important. I'm reminded of a time when an application was accidentally terminated. Fortunately for that application, they had good design time automation available that allowed them to quickly deploy their infrastructure as code as well as their actual application code. That allowed them to restore their operations very swiftly. Next, we have observability. Particularly as our applications grow more distributed, more microservice oriented, more modern, there's also more complexity. It's quite important that we have the right telemetry with logs, metrics, and traces that allow us to swiftly determine what is the root cause of a failure. And in the observability column of number 2, you see some AWS services that help us receive this telemetry as quickly as possible, put it together, and be able to use that for troubleshooting purposes. Then we have number 3, recovery. Under recovery, we talked a little bit about strategies and procedures. Some might be automated, for example, automated runbooks with SNS and Lambdas. Some might be still manual. At Capital One, we are always striving to improve our mean time to recover. Part of that also includes testing and refining our incident response processes. We need to make sure the right person is on call. We need to make sure that the right person is reached. And we need to make sure that that right person knows what to do when they see a particular failure. Those things are all covered by our standard operating procedures and checklists. Next up, we have our reliability lens. Earlier I mentioned SLOs, and here we'll talk about them a little bit longer. The SLOs are very important to define because they also help us understand what is the right level of investment that we need to put into this particular system to make it reliable. We also need to understand what are the SLOs, particularly what different aspects of SLOs are we trying to cover for the business requirements. For example, for some applications, it may be all about availability. But for other applications, it may be all about the data experience and the freshness of that data and the accuracy of that data. It just kind of depends on what the application's purpose is and what the business feels is the critical transactions of that application. Another important consideration for reliability is security. And this is because we want to make sure that we understand the security implications of our architecture, and we want to be thoughtful about how can we achieve greater security. Another reliability aspect here is performance. We want to make sure that the application performs adequately, or more than adequately. It really surpasses the customer expectations. There's a lot that goes into performance. Definitely key is making sure you are able to do performance testing, and it also helps you make sure you have the right level of resources, the right sizing of resources, and as we talked about in the resiliency lens, the right capacity to support those resources. So for example, if your application is relying on a very particular instance type, you want to make sure that instance type is available, and that also helps your performance. Last but not least, you want to consider cost. We want to make sure from a reliability lens, as mentioned with the SLOs, that it's the right level of investment that's balanced by the reliability that is achieved. So we want to make sure that the architecture is cost conscious and that things such as selecting the right resource types have been done to maximize the cost efficiency. With that in mind, our previously highly resilient and available and recoverable system and application is now augmented to support reliability. What you see in number 1 is some native AWS services that help us do cost optimization. In number 2, you see another set of services that help us understand what is our security posture, and they help provide the security guardrails that we need to help ensure that our applications can operate securely. This is important both from a preventive perspective as well as a detective perspective. With that, that brings us to where Capital One is today. So today we're all in on cloud. We're steadily incorporating SRE. We're applying these 3 lenses to our fleet of over 2,000 applications to increase their stability. These applications, some are internal facing, some are customer facing, but for all of them, we want to make sure that we can provide the best experiences possible. In the future, we also hope to focus on refining our data layer patterns improving our dependency management, and also really emphasizing our architecture principles, for example, as we mentioned today, observability and stability. With that, I'm going to turn it back to Don.
Thanks so much for that, Tanu. That was really interesting hearing about how Capital One solved that. For all the participants, I encourage you to check out some of these links available on this page. First is the AWS Well-Architected Framework. It is a series of white papers on best practices for building in the cloud. And building on top of those are a variety of other resources, such as our AWS Well-Architected Labs, which are hands-on labs to help you build using architectural best practices. The AWS Architecture Center, which is our official repository for all architecture resources. And finally, the AWS Solutions Library, which contain vetted reference implementations of well-architected patterns. So very much appreciate the time you've spent here today. Hope you've all learned something. Look forward to helping you go out and build something.